Over the past couple of years, automotive manufacturers have been turning away from fitting their performance cars with big, naturally aspirated engines to smaller, more modern turbocharged models to meet with government emission regulations. The government has been doing so to improve the natural environment to prevent global problems, such as global warming. Carbon dioxide is most commonly known to be produced from a car through the internal combustion engine, where, in terms of gasoline engines, an intake valve opens, which lets a mixture of gasoline and air into the cylinder compartment, and the cylinder compresses the mixture. Once compressed, the spark plug ignites the mixture, which causes a combustion and forces the piston down. Then, the exhaust valve opens, and the piston pushes again to let the exhaust gases out, which is carbon dioxide. As this cycle continues, power is produced from the cylinders, continuing their rotational cycle. It should also be known that the chemical formula for gasoline is C8H18, which is a mixture of 8 carbon atoms and 18 hydrogen atoms. Simply, carbon dioxide is produced when carbon from the gasoline and oxygen are combined after the combustion and is then exhausted into the world through the exhaust pipes. Manufacturers have also been making improvements to improve emissions on their performance models by fitting turbochargers and superchargers to their internal combustion engines, which can also improve power outputs because there is more air being compressed into the engine. Turbocharging can prove to be the most effective in terms of decreasing carbon dioxide outputs because it works when the exhaust gas drives a turbine that spins an air compressor to feed more oxygen into the cylinders, so the engine won't be so reliant on fuel to make power. Supercharging can also be effective, but not as much as turbocharging because although it feeds more oxygen into the cylinders, it does so because it is attached to the crankshaft. So, as the crankshaft spins faster, or as the engine revs higher, air is being sucked into the cylinders to create more power. Recently, Mercedes-AMG has produced the AMG GT lineup that contains continuously upgraded bi-turbo V8s, where Mercedes-Benz trademarked bi-turbo because it is a small twin turbocharged V8 where the turbochargers are in the V of the engine. The AMG GT is the successor to the SLS AMG, which had a bigger, naturally aspirated V8 that wasn't as efficient as the new AMG GT. It would be obvious that the AMG GT produces less carbon dioxide because of its engine's smaller displacement and the use of turbocharging, but I tested to see if the low-end engine found in the AMG GT would produce less carbon dioxide than the top-of-the-line AMG GTR. Considering the GT's engine produces less power and has a rated MPG of 16 city, 22 highway, I predicted that the GTR's engine, with more horsepower and worse MPG, would produce more carbon dioxide, considering that to get the extra power, the engine would need more air and gasoline to make it. So, I would also test to see if the added performance is worth the higher emissions. My research on the car's carbon dioxide emissions came from the Mercedes-AMG website, which, proving my theory, states that the GT emits 261 grams of carbon dioxide every kilometer and the GTR emits 284 grams of carbon dioxide every kilometer. To see if the increase in emissions and lower fuel economy was worth it in performance, I used a realistic racing game, Gran Turismo Sport, to set hot laps in the GT and the GTR, where I would race the car around Willow Springs' Streets of Willow 2.6 km circuit and try to set the fastest laps possible in 3 laps. Since the Gran Turismo Sport video game only contains the AMG GTS, I finely tuned the ride height, suspension firmness, and tire configuration for both models, as well as power and torque to compensate the different models' power outputs. In the GT spec car, I was able to set a lap time of 122.238, which, for its class, is very well. But in the GTR spec car, I was able to set a lap time of 118.131, which is over 4 seconds a lap faster than the GT spec car, and on track means a huge difference in performance. I then calculated each car's emitted grams of carbon dioxide per kilometer from the 2.6 kilometer course, and concluded that the GT emits 678.6 grams of carbon dioxide and the GTR emits 738.4 grams of carbon dioxide, making it a 59.8 gram difference, or 14.56 more grams of carbon dioxide for every second faster than the GT. Based on their emissions, I would conclude that the GTR is definitely worth the extra performance, but as far as pricing go, I would stay in the middle and go for the Mercedes-AMG GTS.